All right, special shout out to Gervin, who convinced me to record the video for you delinquents who decided not to come today. All right, so assuming maybe you didn't see the rule, let me expand out 3 to the power of 5 times 3 to the power of 2. We're not going to do this very often, write out these repeated multiplications, but they're useful in seeing the rule in case it's been a while. Now, when I write that out, I can see there is 7 factors of 3. And what is 3 multiplied by itself 7 times but 3 to the power of 7? There is a rule here that we can use to simplify the product of 2 powers, to make it one single power that's easier, more quick to evaluate in a calculator. Does anyone remember or even just see the rule if it's new to you or if it feels new? Forrest? You add the exponents together. And I'm going to summarize that here. You add the exponents, b plus c, and I'm going to add, because there's always a few, the base stays the same. We do not multiply the bases together. The base stays the same for reasons we looked at above. Base stays the same. Exclamation point. We have a rule for multiplying powers together. Add the exponents. We have a rule for dividing powers too. It's entirely possible. You already know this rule, but let's just motivate it with a couple quick examples. What happens when you divide 5 to the power of 6 by 5 to the power of 2? When you expand everything out, you get 2 factors of 5 on top and 2 on the bottom. They divide to 1. What you're left with is 4 factors of 5. And what is 5 times itself 4 times but 5 to the power of 4? If you can go right from the left column to the right column, fantastic. Good for you. I'm going to write this one out. 4 to the power of 7 divided by 4 to the power of 4. You know what? This is just a good exercise too for when you guys all teach high school math. You're going to do this with your wee little grade 9s. That's a lot of 4s, but 4 of those factors on top will divide out with 4 on the bottom, and you're just left with 3 of them. 4 to the power of 3. Oh, excuse me. There's 3 factors of 4 left. 4 to the power of 3. Somebody different. Do you guys see the rule for how we can combine a division of 2 powers into one single power? You subtract the exponents. That's it. Dividing 2 powers, subtract the exponents. But please add this note. Some of you guys are going to be naughty and do this, but we keep the base the same. Keep the base. I'm using different language. Keep the base. It doesn't change. So multiply powers, you add the exponents. Divide powers, you subtract. We're running out of operations, everybody. There's only so many. I wonder what the rule will be when we do a power of a power. I've done one example here. 5 cubed all squared. That just means 5 cubed times itself, or 5 times 5 times 5 times 5 times 5 times 5. That's 6 factors of 5. 5 to the power of 6. I wonder what will happen if we do 3 squared to the power of 4. 3 squared is 3 times 3. Do that 4 times. Good morning. We have 8 factors of 3. We can write that as 3 to the power of 8. We've used addition, we've used subtraction. I know this is probably almost too easy to ask, but this is a little layup of participation. Take yourself from an S to a G on your learning skills. What's the rule for doing a power of a power? Sullivan? Multiply the exponents. Multiply the exponents. A to the power of B. And we're kind of at the stage now in these academic level math courses. I can just write BC by them, like side by side, and we understand that is multiplication. You guys need the handout? Yeah, it's this one. Is it that one? It is that one. Take one for Claire. Please, 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 everybody. Add this little note. Base stays the same. All right. So there we go. We've basically condensed a whole lesson from grade 9 into 5 minutes there. Let's do a little summary. Let's do some easy examples, make sure we're rock solid, and then we'll take it to the next level a bit and talk about what's expected for you guys as grade 11 math students. So a little summary. To multiply powers with the same base, you add the exponents. And let's just cook up a few examples here. So how about, I got an interesting one. How about we do 4 to the power of 6 times 4? How can we write that as a single power? Multiply powers, add the exponents. What's the exponent on 4? There's no exponent there. It's like an assumed 1. Yes. So 6 to 1 in honor of our Toronto Maple Leafs. Or as my dad would say, the make you laughs. I digress. I actually just stress cleaned the entire house while the game was on. Didn't watch a single thing, but it got me through, and I don't care. I don't care. You might say, "Well, why are you talking about it if you don't care?" I don't care. Let's move on. But yeah, 4 to the power of 7, and whatever that is, 4 to the power of 7. Let's just hammer it out. 16,384. Now, I'm going to do one more example in here because I have space. Here's what I expect to see from you guys. If I give you something like, I don't know, 3 to the power, we'll keep the numbers small, 3 to the power of 2 times 3 to the power of 5. What I expect from you guys, the bare minimum. We expect you guys to show us you know how to use exponent rules. Add the exponents. I don't need you to write 2 plus 5. And then evaluate on your calculator. Now you can do 3 to the power of 7. It's just you got to convince your math teacher that you understand how the exponent rules work. 3 to the power of 7, 2,187. Like all of your guys' calculators, you can put in 3 squared times 3 to the power of 5, and it will give you this answer. We want to see you apply the exponent rules. All right, let's add to our summary table. Let's do one for dividing powers with the same base. We subtract the exponents, is what we talked about. All right, as an example, I don't know, let's do 8 to the power of 10 divided by 8 to the power of 8. So we would do 8 to the power of 10 minus 8. Subtract the exponents. So that's equivalent to, as a single power, 8 squared. And 8 squared is 64. Please don't make me beg, but please do not divide 8 by 8. This is not equal to 1 to the power of 2. The base stays the same. And no matter how many times I say that, there will be a small handful of you that keeps dividing the bases and you'll keep doing 1. No, the base stays the same. What is actually expected out in the wild, doing some practice for me on a test. Here's another example. How about 9 to the power of 6 divided by 9 to the power of 3? All I need from you guys, subtract the exponents. Obviously, 6 minus 3 is 3. And then evaluate on your calculator. 9 cubed, whatever that is. 729, of course. I knew that. All right, lastly, let's mirror that. Just get a couple of examples down here to simplify a power of power, multiply the exponents. So as an example, let's do, I'll go crazy here in a second. Let's do this. Let's do 5 to the power of 2 to the power of 4. So we know that that's equal to 5 to the power of 2 times 4, or 5 to the power of 8. Write it as a single power, and then evaluate. 5 to the power of 8 is going to be relatively big. That's okay. Of course, you guys all know your 5 times tables up into the hundreds of thousands. 390,625. But you know what? Let me cook up another example here. How about this? Let's go crazy. How about 4 to the power of negative 2 to the power of negative 3? We saw from the motivation that exponents that are negative could actually give us something meaningful. Do we actually have to work with negative exponents here? Or can we just use our power rule? Guys, what's minus 2 times minus 3? No. Multiply them. It's 6. Yeah, we can just write that as 4 to the power of 6, which we can evaluate on our calculator. The exponent rules are our friend. They can help make complicated scenarios like that into something more manageable. 4096. All right. If you're feeling very good about this, that's great, because this is all from grade 9. Everybody did this. Can you guys humor me and try these 6? Use the exponent rule, write down the single power, and then evaluate on your calculator. If it feels easy for you, fantastic. Make sure your seat partners are good, and then we'll move on. I'll pause the video, actually. I'll do my attendance while you guys do those. And then we'll talk about... So listen, what I need from you guys. I get your calculators can do this in one step. I need you guys to show me that you can use the exponent rules. That is like 6 to the power of 5. And I believe that is 7,776. I think. I heard somebody say that, and I remember that from the last time I did this note. 5 squared times 5 to the power of 4. Add the exponents. I don't need you to write me 2 plus 4. I just need you to show me, though, that you added the exponents and whatever 5 to the power of 6 is. 15,625. Subtract the exponents. 10 to the power of 1. That's just 10. Subtract the exponents. 7 to the power of 4. This one ends with a 1. 3961? Yeah? Is it 3,961 or 3,961? 2,401. I was so close. Very close. Almost there. I was like 2/3 later. And then 10 to the power of 8, which is a large number. That's like 100 billion. 10 to the power of 8. Does it fit on my calculator? It's a 1 with 8 zeros on the end. 100 billion. All right, and then lastly, power of power, 5 to the power of 4. $625. All right, guys. My sense is we're feeling okay. It's grade 9 stuff, but things will escalate quickly, especially for the people that took grade 10 applied last semester, and maybe for some who struggled with the grade 10 course. So we need to make sure everything's rock solid here. Let's escalate things a bit. Let's do an example like this and talk about why the exponent rules are necessary. Can you guys humor me? Can you guys do... What if we were just to like say, okay, well, I'm just going to do 2 to the power of 45, write down that number. 2 to the power of 65, write down that number. Then I'll multiply them. What do you get when you do 2 to the power of 45? Does it fit on your calculator screen?
Yeah.
No, it doesn't. You got scientific notation, which even though some of you guys are taking chemistry, biology, physics, some of you guys maybe haven't used scientific notation before. We'll talk about it. But it's too big to fit in your screen. In fact, if you guys can humor me, try 2 to the power of 105. Get an even bigger number. 4 times 10 to the 31. So that's basically a 4 with 31 zeros after it. Now humor me some more. You can actually keep going with powers of 2 to get a number so big your calculator can't fit it in its random access memory. Can you find the power of 2 that breaks your calculator? And this gives you an error message. For most of us, it'll be a specific number. If you're on your phone, it should be a higher number. I don't know why you're on your phone anyway, because phones are often away during instructional time. That's for board policy, right? As it has been all year. Like I tried 200, and I still got something. I'm trying 300. I still got something. 350. Math error. It's not that that number doesn't exist. It's too big for all the ones and zeros to fit in our circuitry. But can you guys find what number breaks it specifically? 300 was okay. 350, too big. This is just a fun exercise, just to, to get through the period and survive. 300 was good. 350 was bad. You said 333 works? I got, for me, it didn't work.
Yeah, I got 332.
Okay. Yeah, mine's the same. So 2 to the power of 332 is about 8.7 times 10 to the power of 99. Basically a 9 with 99 zeros after it. Incredibly large. Anything bigger, your calculator can't handle that number. It's not that it doesn't exist. So when the exponent rules can actually help us evaluate things where the exponents are massive and our calculators can't handle it. Let's do A together. I'll get you guys to do B. Here is what I need from you guys. Basically the minimum work I need you guys to show me. We need to add those exponents on top because we're multiplying two powers. I don't need you to show me 45 and 65. We're not in grade school. I know you guys can do that on a calculator or with mental math. It's 110. Now that we've written the top as a single power, we have a quotient, a division of two powers. You can now subtract the exponents. I don't need you to write out 110 minus 105. That's obviously 5. And look, that big messy expression is equivalent to 2 to the power of 5, which we can evaluate quickly in our calculators, 32. Can you guys do B? I'll have a sip of coffee while you do B. Do the top, single power. Do the bottom, single power. Divide the remaining powers, and let's see what the result is. I'm pretty sure 3 to the power of 200 breaks your calculator. It's too big. No, it almost does. Almost. I'm going to sit on my hands and resist the urge to do it for like 30 more seconds. You guys give it a try. $243 sounds about right. I'm going to catch up here. Yeah. So on the top, add the exponents, 3 to the power of 300. On the bottom, multiply the exponents, 3 to the power of 295. Now we can divide those two powers, subtract the exponents. If you did 1 to the power of 5, keep the base the same. Stop doing that. 3 to the power of 5, which is 243, I think I heard, right? All right, guys. Both classes after your grade 9 course should be expected to do things like that. Both classes in grade 9 also worked with monomials. We're going to be taking these to the next level tomorrow, so you want to make sure you have these down. And our practice today is actually focused on working with monomials here. Gervin, you with me here? Not convinced. Too many Timbits. I think you're on a sugar high. Let's... Yes, they're full of sugar. How do we multiply monomials together? I'm going to write a rule down here. Can you guys jot this down? The rule is basically multiply what you can. Multiply what you can. What do I mean by that? Multiply what you can. What I mean by that is, I see a 3, I see a 6. I can multiply 3 and 6 together. They're numbers. Let's multiply them. That's 18. Just multiply them. And then I have a power of A, and I have another power of A. I can multiply powers of A together using my rule. That's like A to the power of 1. Now I'm going to show this work I don't need you to, though. I'm just going to show it just to make sure we're all comfortable. We're going to add those exponents. And I'm multiplying some powers of b. I can multiply them together by adding the exponents. Hey guys, I'll say it again. We're having fun today, and I'm kind of in a lighthearted, joking mood. But in all seriousness, we have to be solid with this stuff so that tomorrow is easy, so that Monday is easy, because that's when we start to ramp it up both days. So please follow along, because even if you're remember this and are fine with it from grade 9, there's we got a wide variety of learners in the class from all different course streams. You got to make sure you're respecting people trying to concentrate. Make sense?
Yes, sir.
Yeah, makes sense. Do you say yeah, sure, or yes, sir?
I think yes, sir.
Okay. All right, that's a joke too. All right, let's do B. Now notice, guys, with A, we added the exponents. Did we add the numbers together? No, because 6 times 3 is 18. 6 times 3 is not 9. We don't add the numbers. In example B, when dividing monomials, we divide what we can. Divide what you can. Divide what you can. You can. What do I mean by that? You divide 6 and 2. 6 divided by 2 is 3. Some of you guys are going to get into, yes? Yes, but here's the thing. Some of you guys are going to get in this idea, subtract. But no, we subtract exponents when dividing powers. When dividing numbers, you just divide the numbers. 6 divided by 2 is 3, last time I checked. Now you divide the x's and divide the y's. You have to divide the things that you're allowed to divide together. When you divide powers, you subtract the exponents, 6 minus 5. When you divide powers, you subtract the exponents, 10 minus 5. Now, most of you will just be able to go, that's x to the power of 1, or just x. I'm totally fine. Most of you guys can just go from here to here. Most of you guys can go from here to here. That is totally acceptable. Most of you guys can do that. If you need the intermediate step, please do that. Now, for part C, my tip for you guys, when you're doing some kind of monomial to a power, my tip for you guys is this: apply the exponent to everything. Apply the exponent. Exponent has an E out front. Exponent to everything. What do I mean by that? Get my face out of here. So when we're doing 3xy squared, we have to do 3 squared, we have to do x squared, and we have to do y squared. It looks like this. Square 3, square x, and square y. Basically square everything. And we wouldn't just leave 3 squared as it is. We know 3 squared is 9. This would be equal to 9x squared, y squared. Okay, and again, I'm totally happy and fine if you are capable of going right to that final answer there. Can you guys try the remaining 3? Use the same idea. Give those a try. Our practice today is focused on these. It's a more, I'm not even going to say difficult. It's very manageable, but just a bit more advanced than just the basic exponent rules. So I'm going to pass that practice around while you guys try those 3. All right, we're going to see how you guys did. We're going to resume. I'm going to show an extra step here. You do not need to show this step, but 5 times 2 is 10. Did you write 7? If so, multiply what you can. 5 times 2 is 10. But we will add the powers because we're multiplying, or add the exponents. We're multiplying those powers. 10, x to the power of 7, y to the power of 12. How did I do? I did okay? Okay, you guys would tell me if I did something wrong. 25 divided by 5. It's not 20, 5. And then subtract the a exponents. Subtract the b exponents. Subtract the c exponents. A5, B5, C3. Again, if you went right there, I'm happy. That makes me glad. Okay, I don't need that intermediate step. You may want to write down this intermediate step. If this one was the one you had to think hard about, Apply the 3 to everything. 4 cubed. X squared cubed. Y cubed also cubed. And then use our rule. 4 cubed, I know this. I should know this. I have several math degrees. 64? Is it 64? Well, more blank stares than usual. What are you guys talking about? 4 cubed is totally 64. You bunch of... Oh, I'm on YouTube, so can't call you guys names. Multiply the exponents. X to the power 6, multiply the exponents. Y to the power of 9. If you were able to go right here, I'm okay with that. All right, video over.